In Chapter 8, we're going to start looking at things like roots and radicals. Okay, that's better. And we're going to focus on radicals first in section 8.1. When we have looked at things so far, we have looked at exponents and understand that 2 to the third power means 2 times itself 3 times. In section 8.1, we're going to go backwards. We're going to ask questions like, what to the third power is equal to 8? If I have 5 squared equal to 25, we can talk about the square root of 25, or ask the question, what number squared is 25? In general, if b to the n is equal to a, we say that b is the nth root of a. So since 3 to the 4th power is 81, we say that 3 is the 4th root of 81. Since 2 to the 5th power is 32, we say that 2 is the 5th root of 32. For numbers or roots such as 2 and 3, instead of saying the 2th root or the 3rd root, we talk about the square root. So again, since 5 squared is 25, we say 5 is the square root of 25. Or since 2 cubed is 8, we say that 2 is the cube root of 8. Now, students, the first question I get is, well, how do we know what that is? When our numbers are small numbers like 8 and 16 and 25 and 49, coming up with square roots or sometimes even cube roots and 4th roots are things that we can just see in our mind. We know how 25 breaks down and 16 and 81 breaks apart. But if the numbers get very much bigger, then you just have to figure out what goes into the number. For example, 243. If I want to break it down, I recognize that 3 goes into it. And when I get to there, then 3 times 81 is 243. I know 81 is 9 and 9, and that the 9s break apart, each of them, into 3 times 3. So then if I look and I count my 3s, I notice that all of the factors are the same. And what I really have is 3 multiplied times itself 5 times. So if I was asked, I would say 3 is the 5th root of 243. Now, instead of being asked in words, what is the cube root of 8 or the square root of 25 or the 5th root of 32, we'll use a radical, like I did right here, to ask the question. If I want to know the cube root of 8, I'm going to put a little 3 on the outside of my radical symbol. This means cube root of 8. If I want the 4th root of 16, also is 2, I'm going to put a 4 out there. If there's no number written here in this little v, it's understood to be a 2. And I want the square root of 49. And so I think, well, what do I square to get 49? And that answer is 7. Or what do I square to get 64? And that number would be 8. If I'm asked to find the 5th root of 32, we figure out, what do I multiply times itself 5 times to get 32? And that answer will be 2. This symbol, this radical symbol, asks for roots. And again, if there's no number written out in front, it's understood to be a 2, and some students do better in later sections, especially if they write that little 2 in there. But if we're not asking for a square root, there'll be a number there indicating what root we're being asked to find. Now, since I can square both 3 and -3 and get 9, two different numbers squared is equal to 9, we have to make a definition for this symbol. Because I don't know when it asks me for the square root of 9, am I supposed to answer 3 or am I supposed to answer -3? Because each of those numbers squared, both of them give me 9. This radical symbol here says I'm only going to give the positive answer. That's the way it's defined, and your book goes through, and in one of those colored boxes it shows definitions, and it has A's and negative A's, and might be kind of confusing, but what it says is this symbol means I'm only going to give the positive answer. I'm not going to write down -3. If I'm supposed to answer -3 instead of 3, they'll say tell me the opposite of the square root of 9, which means a -3. Now notice that this situation is only true if we have even exponents. If I take 2 to the 4th power, or if I take -2 to the 4th power, I get 16 either way. But if this is the symbol that's written on my page, the only answer I'm going to give is +2. Now realize that if I pick an odd exponent, and I raise 2 to the 3rd power, I'm going to get 8. But if I raise -2 to the 3rd power, I get -8. So when I see something like the cube root of 8 on my page, the only possible answer there is +2. -2 isn't even an option. If I'm asked to find the cube root of -125, that's okay. And that answer is going to be a -5. If my root is odd, there's only one answer, and it's going to be a positive number if what's under here is positive, and it's going to be a negative number if whatever's under the radical is negative. If my root is even, then I'm only going to give the positive answer. There are two possibilities, but this symbol means I'm going to give what's called the principal 4th root, or the principal square root, meaning the positive one. Now, some rules that we'll find along the way are that if I have the square root of products or quotients, I can take the square root of each piece. So if I'm asked to find the square root of 25 over 64, I can take the square root of the top and the square root of the bottom separately and call that 5 over 8. We're going to find out and use a lot later down the line that this is also true for products. If I have the square root of a product or a cube root of a product of things. If I'm asked to find the cube root of 8 over 27, I can think of the cube root of 8 over the cube root of 27 and call that 2 over 3. Now if I have decimals, I don't really like decimals, but this book throws some in from time to time. And the way I would recommend doing it with a decimal to simplify and find the square root of 0.01 is I would recommend writing it as a fraction. The 1 is in the tenths hundredths place, so this means 1 over 100. And if I take the square root of 1, I get 1 over the square root of 100, which is 10. And I can write it that way. Your book gives a lot of good examples on these sorts of things, and in this section you're going to be asked to simplify and find the square roots of things like 25 over 64, or the cube root of 8, or the square root of 9. Some of the numbers get a little bit bigger, like 243s and 625s, that sort of thing. But pretty much this is what we're practicing in section 8.1. The homework assignment from section 8.1 will be the following problems. Let's do 10 to 35, counting by fives, and then hop to 50 and go to 65, is all counting by fives. Your book also talks about some graphs, but we don't worry so much about the graphs of these radical functions, not in intermediate algebra class.